Good morning, this is Miss Clark. We're going over lesson 5.09, Isosceles and Equilateral Triangles. In this lesson, you can prove that base angles of isosceles triangles are congruent, problems involving the measures of isosceles triangles, and equilateral triangles. Here are your basic vocabulary for this lesson. I'm not going to read each one to you, but you can snip this or copy all these slides. An equilateral triangle is a triangle with three congruent sides. Since it has three congruent sides, it also has three congruent angles. And then an isosceles triangle is a triangle has two congruent legs, and those base angles opposite of the legs are congruent to each other. So given that triangle ABC is an isosceles triangle, what is the measure of angle B? So we know that the interior angles of any triangle add up to 180 degrees. So we can take 180 and subtract 86, the angle that we know. And that gives us 94 degrees. So we know that it's an isosceles, so these angles are congruent, so they have to be equal each other. So we just have to take 94 and divide it by 2, and that gives us 47 degrees for each base angle. So now we're going to do the on your own practice, so please play along at home. So the on your own practice for 509, the first question, we're going to do a proof. We're given that line CD bisects angle C of the isosceles triangle ABC. So that's our given. Oops. Then it shows that AC is congruent to AB. We know that the two legs on an isosceles triangle are congruent. So that's the definition of an isosceles triangle. Now, we know that these two angles, ACD and BCD, are congruent because that is the definition of an angle bisector. When you bisect an angle, you get two equal angles. And then line CD is congruent to line CD. Reflexive. Remember, when I see my reflection, it is equal to myself. A line segment is equal to itself. And then, so now we have side, angle, side. And those two triangles are congruent because side, angle, side, congruence postulate. And we know that angle A is congruent to angle B because corresponding parts of congruent triangles are congruent. Check our answer. It gives us our explanation. Let's go to the next one. All right, given that line CD is perpendicular bisector of AB and angle A is congruent to angle B in triangle ABC. So angle A is congruent to angle B is a given. And CD is the perpendicular bisector is also a given. Now we know that these two angles here, since this is a perpendicular bisector, are both right angles. And that is the definition of a perpendicular bisector. And we know that they are congruent to each other because when you have a perpendicular bisector it makes right angles, and all right angles are congruent. Once again, CD is congruent to itself, that reflexive property. And triangle ACD is congruent to BCD. And we had angle, angle, side. So we know that AC is congruent to BC because corresponding parts of congruent triangles are congruent. And this is an isosceles triangle because two legs are congruent. And that is the definition of an isosceles triangle. It has two congruent legs. All right, these with our algebra, I'm going to take a snip so we can do some work. All right, so angle, we know this is, there we go. An isosceles triangle because it has two congruent legs, which means these base angles are also congruent. So the measure of angle A is equal to the measure of angle B. So we can set these two equations equal to each other so we can find out what x is. So we subtract 4x from both sides. We get x plus 7 equals negative 3. We're going to subtract 7 from both sides. Next equals negative 10. So we plug that back in to find out what these angle measures are. It gives us negative 40. Okay. I thought something was wrong because that's supposed to be 10. Okay. So, start this again. We're going to subtract 4x from both sides. And we're left with 7 on this side and x minus 3 on this side. Add 3 to both sides and we get 10 equals x. So this would be positive 40 plus 7 is 47. So we know that these two measures are 47 each. So to find C, we can take 180 and subtract 47 minus 47 because interior equal 180, and we get the angle C equals 86 degrees. All right, explanation, next one. I'm going to take a snip of this one again. See if we can do this work. Alright, so the measure on this one of angle A is 72. So that means B is also 72 degrees. And to get angle C, we will subtract 72 twice. 80 minus 72 minus 72, and that leaves us with 36 for angle C. So the measure of angle B is 8y minus 16, but we know that B is equal to 72, so we add 16 on both sides. 88 equals 8y divided by 8, and y equals 11. We know that C is 36, so that equals 36. Divide by 9 on both sides, and x equals 4. Alright, for this one, since C is 72, we would subtract 72 from 180. And that leaves us with 108. Divide that by 2, and that means our angle A and B are 54 degrees. Alright, so now we have side AB is 10x minus 7, and AC is 8x plus 13. And we find x by setting these equal to each other. So 10x minus 7 equals 8x plus 13. We're going to subtract 8x on both sides. That gives us 2x minus 7 equals 13. Add 7 to both sides. You get 2x equals 20. Divide by 2. X equals 10. Go. Alright, ABC is a triangle. The bases are equal. That means the sides are equal. So AC is 3x plus 4, and AB is 5x minus 10. So we have to set those equal to each other and find x. So then we can plug in x to find BC. So we have 5x minus 10 equals 3x plus 4. Subtract 3x on both sides. You get 2x minus 10 equals 4 plus 10 plus 10. 2x equals 14. 2 x equals 7. So we plug in 7 for BC, so 7 times 7 minus 6 equals 49 minus 6, 43. There's your explanation. We're going to skip. Oh, this is an equilateral. Just want to make sure we did some equilateral. So an equiangular triangle also has equal sides. So if BC is 22, that means that AC is also 22, and AB is also 22. So we have to just set these equal to 22 to find our x and y. So 6x plus 4 equals 22. Subtract 4. You get 6x equals 18. Divide by 6. X equals 3. And then 3y plus 1 equals 22. Minus 1 on both sides. 3y equals 21. 3. Y equals 7. Hope I put the right number in there. Let's see how many more we have. I think we have time for one more. Alright, so an equilateral triangle ABC, the measure of angle B is equal to 2x plus 4. Well, equilateral triangles have equal angles, so we just take 180. 180 divided by 3 gives us 60. Okay, so each angle has to be 60 degrees. So 2x plus 4 equals 60. 2x equals